welcome back to my channel, and today we are going to discuss about magic squares. Okay, so let us begin. So first I will tell you the basics of a 3 cross 3, the mathematics behind the 3 cross 3 magic square. So let's begin. 3 cross 3 magic square. First, I will tell you the rules, then we will look at the mathematics behind it. Okay, so you have a 3 cross 3 grid. That means total of 9 cells will be there in this grid. Okay, 3 rows and 3 columns. Okay, we will look at 3 rows and 3 columns. All right, 3 cross 3. Okay, we will label the rows 0, 1, 2, column 0, 1, 2. Okay, so we have to arrange, we have to fill in the values from 1 to 9. That means 1, 2, 3, 4, 5, 6, 7, 8 and 9. We have to fill these values in all these 9 blanks, and you cannot repeat any number twice. So in any row, the sum of all the rows, all the columns and all the diagonals is same. That means, for example, okay, I won't tell you, you can just pause this video and try this out. So one week, how can we fill? We want all the sum of rows, all the sum of columns and all the sum of diagonals would be same. That means the sum of 0 0 0 1 1 2, that will be equal to some e value, suppose, and the second rows elements, right, 1 0 1 1 1 2 would be also e, same sum. Third also same sum. If you sum all the column values, that will be also equal to e. This column's value also e, this column's value also e. And the diagonals, this elements, if you sum up these three elements, if you sum up these three elements, that will also be e. So how can you fill these distinct values in such that these rules are always followed? That is a concept of the magic square. Now you can pause this video and try to fill this magic square out, and then we will discuss the mathematics behind the magic square. Okay, rules, how to so we can solve it using mathematics. Okay, so if I ask you this question, what would be the sum of the numbers 1, 2, 3, 4, so on till 96, 97, 98, 99, 100? That means this, what is the sum of first 100 natural numbers? That is my question. Pause and think about it. Okay, so the mathematicians, they devised a uh, very nice observation of fast how to calculate the sum of any natural number starting from 1 till n in a very fast way. Usually what we will do first 1 plus 2, the result we will add 3. In the calculator we will do that. But the mathematicians observed that if you add 100 and 1, what you will get the sum? 101. What if you add 99 and 2? 99 plus 2 is also 101. 98 and 3, that is also, wait, 99 plus 1, right? Oh wait, we will take till 99. Okay, let us first take till 99. Okay, oh wait, no, it was correct, right? 98 plus 3, 98, 99, 100, 101. Yes, it is 101. 97 and 4, 101. So, so that means if you take the first element and the last element, the second last element and the second element, then you are getting the same constant sum. So you have to add 101 how many number of times? As many pairs are being formed by the numbers. So how many pairs would be formed? there are n numbers, 100 numbers, the total 50 pairs would be formed. 100 by 2 pairs would be formed because every pair has 2 elements. So you just take first half of the elements, right? So that will be 100 upon 2 pairs. So 101 you are adding how many times? 100 by 2 times. So that means you can generalize this. The sum of all the sum of the first rth term and the last n minus rth term would be the constant, and that would be equal to what? 100 plus 1. That means n plus 1. Okay. And n plus 1, how many times you are adding? You have to add n plus 1 as many pairs are being formed. And how many pairs are being formed? Total n numbers are there, and half of them will be the number of pairs. So this is the formula for sum of n natural numbers. I hope you got how this is coming. This result will be used in magic square. Note over here, all these cells we are filling with the values 1 to 9 and no number is being repeated. That means if you add these 3 rows and the sum is also a constant, right? This sum is E, this sum is E, this sum is E, right? So that means we can write the sum E plus E plus E is nothing but the sum of 1 to 9, right? That is till 9 natural numbers you have to find the sum, and we know the formula for that. That is equal to n into n plus 1, and n is, what is a value of n over here? 1 to 9. So n is 9 over here, right? So that means 9 into 10 by 2. So 45. So that means 3 times E is equals to 45 or E is equals to 15. So for a 3 cross 3 magic square, this result is true only for a 3 cross 3 magic square. The sum of all rows will be equal to 15. The sum of first row 15, second row 15, third row 15. The columns, first column's sum would be 15, second column sum would be 15, third column sum would be 15. The value of the principal diagonal sum would be 15 and the secondary diagonal will also be 15. Okay. Okay. So we got this result that for a 3 cross 3 magic square, the magic sum or sum of all the columns is going to be 15, and it is always true. We showed it mathematically. Now, what is this? We can also find another result. Okay. What is the value of this center element? Okay. Notice this center cell is, in all the results, we will try to use the formula of 1 to 9 natural numbers. Okay. We will try to include it. And to get the sum of natural numbers, we will try to include all the 1 to 9 numbers of this square. Okay. So what we will do is, we will include all the cells where this middle cell is common. Okay. See, this diagonal is including this middle cell, correct? This secondary diagonal also has this middle cell common, right? This column is also having this middle cell common, and this row is also having the middle cell common. Okay. And let us write other than this middle cell as A, B, C, D. I am not using E, we will use F, G, H, I, and let us write this middle value as M. Okay. So what is happening? We are adding M how many times? How many yellow marked areas are there? 1, 2, 3, 4. 4 are there, right? So 3 times E, sorry, not E, we are using M. 3 times the middle value. Okay, so I think you have understood what we are doing. We know the sum of this principal diagonal is E, right? And the sum we can write as A plus M plus I, right? So we can write the diagonal as A plus M plus I is equal to the magic sum E, right? Also, we know this secondary diagonals element B plus M plus G is also E. B plus M plus G is also E. Then we know that second, okay, now this row D plus M plus F is also E. D plus M plus F is also E. And also this column C plus M plus H is also E. C plus M plus H is also E. So note A, B, C, D, then I, G, F, H, all the cells have been included. Means apart from M, all the other numbers from 1 to 9 have been added once over here. If we add all these four equations, so only M is being added 4 times. Other elements are added only once. So we can write this summation as A. All the other elements, 8 elements I am writing is as sum of the first 9 natural numbers. Okay, I am writing it in short. Summation of I is equals to n natural numbers, right? I'm writing it directly. 9 into 10 by 2 plus 3 times m is equal to 4 times e. Pause and think how this came. Okay, we just added all these four equations and replaced a plus b plus d plus c plus 1 time m plus I, G, F, H with sum of n natural numbers. Okay, so this was 45 plus 3m is equals to 4 into 15. We know for 3 cross 3 is 15, right? Now we can divide this by 3, right? Plus m is equals to 4 into 5. 5 was a 20. So m is equal to 5. So always in a 3 cross 3 magic square, the middle element m would be 5. Okay, okay, I'm making another magic square over here. So 3 cross 3, 1, 2. The middle element will always be filled with 5. These are the two results that you have to keep in mind. For a 3 cross 3 magic square, this would be always true that the middle element would be filled with 5. You cannot solve the magic square if the middle element is not a 5. Okay, and you have to fill the numbers 1 to 9 in such a way that rows sum to 15. Okay, so let us try to fill it once. Okay, so here the 5 is there and we have to make the sum 15 of this diagonal. So we can fill in 10, right? I will fill it like 8, 2. The sum is 15. Now this diagonal also has to be made 15, right? 5 is already there. What we can fill? 6, 4, right? It is again 15. Now 8 and 6, 14. Yes. So we have to fill 1 over here. If we fill 1 over here, what you have to fill over here? You have to fill 9, right? And what about this? 8, 6 plus 2, 8 already there. So I have to fill 2 over here, but that is not possible. So we will swap 6 and 4. Okay, I will put 6 over here and 4 over here. Okay, so yeah, so 4, 5, 6, but I have to wait. Was that a problem? 6 plus 2, 8. And we have to make 15, not 10. Right. 8 and 15 minus 8. Right, we have to fill in a 7 over here. Yeah. Then 7 and 5 is 12. So 3. Is it satisfying the property of magic square? Let's see. 9, 4, 6. 6 plus 9, 15. Yes, no problem. Yes, it is indeed a magic square. 8 plus 3, 11. 11 and 4 is 15. Yes. So this is definitely a magic square. So hope you like this video. Please share it with your friends, subscribe to my channel and stay tuned. In the next part, we will discuss some applications in the real world of magic square, and after that we will discuss the algorithm that you can write a program in Python to create a magic square. Okay, bye bye and take care.